So the reason we're trying to find the greatest common factor is because we want to be able to factor that out. So when we're looking at something like this, 2x minus 10, there are two terms, the 2x and the negative 10. And I'm wanting to factor out the greatest common factor of these two terms. So the greatest common factor between them is, well, 2. 2 goes into 2x, 2 goes into 10, and there's nothing else that's in common between each of them. The reason this is the greatest common factor is because I can rewrite each of them as 2 times something. So 2x is 2 times x, negative 10 is 2 times negative 5. And so when I'm talking about factoring this out, I'm going to write it as 2 on the outside of the parentheses, and then whatever else is needed to make these numbers on the inside of the parentheses. So I'm going to do an x for the first term, because 2 times x is 2x. I'm going to do a negative 5 for the second term, because 2 times negative 5 is negative 10. Essentially what I'm doing here is I'm doing the distributive property in reverse. You'll notice if I was to do the distributive property, I'd take this 2 times x to give me 2x. I take 2 times 5 to give me negative 10, which is exactly where we started, except I'm wanting to go in that direction. I want to write it as a product instead of just simplifying. So that's the process we're going to do here. Is we're going to first figure out what the greatest common factor is. So between 9 and 36, the greatest common factor is 9. Between z cubed and z squared, I'm limited by the z squared. So I'll write down what my greatest common factor is. And then there's two terms up here, so I'm going to have two terms on the inside of the parentheses. I'm going to say, what do I need to multiply? What would I need to multiply by this 2z squared to get the 2z cubed? Well, here I need to multiply by z, because 9z squared times z is 9z cubed. Here, let's see, I want to take something times 9z squared to get 36z squared. Well, that's 4, because 4 times 9 is 36, and the z squareds already work out. So to factor this, you can see I get 9z squared times z plus 5. Same thing goes even if we have 3 terms. I'll just look through it and follow the exact same pattern. The greatest common factor between 6, 8, and 18, I'm noticing they're all even. This one is 2 times 3, and I've noticed 3 is not a factor of either, well, of this one at least. So the coefficient here is going to be 2. I'm kind of limited there. Between my a's, I have an a squared, an a to the first, and an a cubed, so I'm limited by the a to the first right here. B squared, b cubed, and b to the fourth, I'm limited by the b squared. So my greatest common factor is 2ab squared. And I'm going to have 3 terms on the inside of the parentheses, 1 for each of these. So I just need to ask myself, what number would I multiply by 2ab squared to get 6a squared b squared? Well, blank times 3 equals 6, blank times 2 equals 6. A little Freudian slip there. 3 times 2 is 6, okay. A times a squared is, a times a is going to give me a squared. And I don't need to multiply anything by the b to get b squared. Alright, what number times 2 gives me 8? You'll notice when I'm asking this, I'm really just doing division. So instead of going backwards like this, you could go forwards. You could say 8 divided by 2 is 4. A divided by a is 1, so I don't need to write anything. B squared divided by b cubed divided by b squared is b. And let's see, 18 divided by 2 is 9. A squared, or a cubed divided by a is a squared. B to the fourth divided by b squared is b squared. The only thing I might want to do here, this was not given to me in standard form, and you'll notice the polynomial that's on the inside of these parentheses is also not in standard form. So I might want to actually take a moment and rewrite it, rearrange these terms so that it is in standard form. This should have been a squared. We get 9a squared b squared plus 3a minus 4b.